All right, folks, I'm going to start going through the Unit 7 study guide. This video will be page 1, so whatever's on page 1 is what I'm going to get through. So question number 1, I've given you a lovely graph, and it says to find the period, amplitude, vertical shift, or phase shift for each function. The ones you need to answer are the ones that are actually in the question. So in this case, I want period, amplitude, and a vertical shift. So let's start with period. One of the things I talked about was to find the period, it's easiest to go maximum to maximum. Look where you start here. This is on the y-axis. Look where you end here. That's 2 pi. So one full period is going to be 2 pi. Amplitude. Let me go ahead and erase what I've already marked there. Amplitude is your, remember, it's the distance from the midline to either the maximum or minimum. So I actually start by finding the midline here first. And if I look at this, my highest point here is at 4. My lowest point here is going to be on the x-axis, which is 0. So if I kind of draw little lines here, right between these two would be the midline. So there's my midline of 2. Love the notification. All right, I need an amplitude here. Amplitude is going to be the distance from this midline to this maximum here, or the midline to the minimum. In either case, your amplitude is going to be 2. Your vertical shift. Now, the normal sine and cosine curves sit on the x-axis as their midline. Clearly, our midline has shifted. In this case, it's shifted up 2. So vertical shift is going to be up 2. All right, so that's number 1. Let me slide on over to number 2. So same thing. I want a period, an amplitude, and a vertical shift in this case. So let's find the period. Now in this case, I'm going to zoom in a little bit better on the picture here. In this case, I'm going to go minimum to minimum. I like if I can start on the y-axis because that starts me at a 0, and then this minimum is sitting at pi, so my period is going to be pi. Amplitude in this case, I'm going to do the same thing I did in the last one. My maximum here is at 3. My minimum here is at -1. So if I go halfway between those, should be at +1 there. So how does this help me find my amplitude? Well, amplitude is going to be the distance from this midline up to the maximum. So 2 units up, or, excuse me, the distance from the midline down to the minimum. So that would be 2 units down. So amplitude is going to be 2 here. Vertical shift, because your midline is not sitting on the x-axis, there is a vertical shift here. It moved up from the x-axis, so up 1 unit. All right, so that's if I give you some lovely graphs. You can find specific features that I've asked for. Now, for 3 and 4, I've given you equations, and I've asked you to find specific pieces of information. Now, we've been doing this for a while anytime we were dealing with graphing. So first things first, period. If I look at x, nothing is being multiplied times x. So that means I'm going to go for the standard period for cosine, which is going to be 2 pi. Amplitude. Amplitude is the number that's being multiplied times your cosine function. In this case, it's +9. Now, the negative, remember, is not part of the amplitude. That's its own little key feature for a reflection. But that amplitude is going to be 9. Vertical shift, if you go from your cosine function here and you see that you are subtracting 4, this -4 is going to be your vertical shift. Since it's minus, we're going to go down 4. And the last but not least part is we're looking for a phase shift here. Now, my way of finding phase shift that I find easiest is to take this whole expression, the whole thing, and set it equal to 0. So x plus pi over 2 equals 0, which makes x equal to -pi over 2. Now that phase shift, because it's x equals a -pi over 2, is going to be left pi over 2. Now you don't have to worry how many spaces that is. That's not important in terms of actually identifying what the phase shift is. The number of spaces will be important when we have to graph it. So number 3 is done. Number 4. Same type of problem. We've got a graph here, or I'm sorry, an equation here. Period, amplitude, vertical shift, phase shift. So period, let's find x. Ooh, something's being multiplied times x here. So this 2 is going to affect your period. You're going to take the standard period of 2 pi and divide by that number that's being multiplied times x. So when you simplify it, your period is going to be pi here. Amplitude is the number that's being multiplied times sine. In this case, there is no value written there, so we assume it is a 1. Vertical shift, we've got a +5 here at the end of the function, so it's going to be a vertical shift up 5 units. And then phase shift. Now, this is where it's going to be super important that you pay attention to this whole expression. This 2 in front of the x is going to affect the phase shift. So if you're used to just looking at it and say, oh, it's something to do with the pi over 3, not in this case. So I'm going to take this whole expression, the whole thing, and I am going to set it equal to 0. So 2x minus pi over 3 is equal to 0, which makes 2x equal to pi over 3. I'm going to divide by 2, which means the same thing as multiplying by 1/2. All right, so this is going to give me x is equal to pi over 6. Now that pi over 6 is positive, so that means I'm going to shift to the right pi over 6 units. Now again, I'm not worried about how many spaces that would be on the graph. It is unimportant in this problem. You just need to identify what the actual phase shift is. All right, so whether you're given a graph or you're given an equation, you should be able to identify those key features. All right, now the last problem on page 1 here is I've given you a graph and I want to write 2 equations, one sine and one cosine for the graph shown. Here's the thing with this. This particular problem has a lot of solutions. So for equation 1, I'm going to identify this one as my sine curve. And then for equation 2, I'll make this one my cosine curve, just for my own well-being. All right. So for sine here, I'm going to take a look at where I'm starting. Now, I am starting here at the origin, and I have a 1 complete cycle. Okay, so down and back up, and then back to the midline here at 2 pi. So that means my period is 2 pi here, which is good to know. Let's talk amplitude. So amplitude is going to be from that midline up to the top or midline to the bottom. If I look at this, so midline up to the top is 3 units here, down to the bottom 3. All right, so I've got an amplitude of 3. So sine here, let's kind of put this together. Let me call this y equals, because I want an equation, so you need to have it equal to something. Amplitude is 3. We've got sine, because the period is a standard period of 2 pi, it's just going to be sine of x. The only thing to pay attention to with the sine curve here, if you're starting here, because this curve drops down, this is a reflected sine curve. So that would be -3 sine of x. Okay, so that's if you're doing sine. Now, you could have also started here for sine, right here. You could have also started here for sine. You could have started here for sine. What you want to make sure that you're doing with sine, though, is that you're starting at the midline, okay? Now, I'm going to delete all of this stuff that I just did. Delete, delete, delete. I'm not going to delete the period and the amplitude, though, because that's still the period and amplitude. But for cosine, I need to figure out if I'm going to start at the maximum or the minimum. Now, for me, I'm going to go ahead and start at the maximum here, which means I'm starting at -pi over 2, okay, which means I've shifted the graph to the left. So how is this going to work for me? Well, y equals, amplitude is still 3. I've got cosine of x. Now, if I want to start at -pi over 2, that means in my equation I had to have had x plus pi over 2. So period is still 2 pi, so no change to x. Amplitude is 3. I still have the 3 here. Cosine should start off-center positive or off-center high, which is what this is, so there's no reflection needed here. All right, so this video takes us through page 1. I will continue videos for the other pages. Let me know if you guys have any questions or concerns.